Welcome to part 2 of 8.6, which this portion of the video is going to be talking about rational forms of radicals. And so it's something you're going to, need to know how to do is how to switch back and forth between the two different forms. Now, the root symbol, as we talked about in the first video, is going to be called radical form because the root symbol is a radical. Now, every single radical or root can also be written as rational powers, which is going to be called rational form. So if we look at my example here on the left, we've got the nth root of a can be written as a to the 1 over n power. So whatever root you have right here could be written as a fraction with that number on the bottom. So the example I've got below is the cube root of 9 could be written as 9 to the 1/3 power. Now, you'll see that the example I picked here doesn't simplify. If it did simplify, we could go further and write it as, just simplify the portions of it down. But the cube root of 9 isn't anything nice. If this was 8 to the 1/3 power, then the answer would be 2. But it's cube root. Okay, on the right-hand side is kind of the more complex version of the same topic. So if we have the nth root of a to the m power, that could actually be written as a single number. And it could be written as a to the m over n. So on the left-hand side, the one we talked about first, is that the bottom number of the fraction power is the root. Well, the top number of the fraction is going to be the power. So right here we had a to the m power, and it's still to the m power, also to the nth root. Now those two can kind of be in the same spot, and those two numbers stand for different things. They still work like normal numbers, so like if this was 10 on top and 5 on the bottom, then we could take 10 divided by 5 and make it a 2 instead. So they each have their separate jobs, but they can be simplified. So the example I've got below here is cube root of 8 squared. And so then that would give me 8 to the 2/3 power. The 3 being the root, the 2 being the power. This one can be simplified. So cube root of 8 is 2, squared would be 4. Okay, let's do some examples together to kind of show you how this actually works. So the first example I've got is to write the expression negative 125 to the 2/3 power in radical form and simplify it. Now on the left-hand side, you see I've got some notes here about this. It says the order of the power and the root don't matter. It works either way. So that means that you can choose whether you want to square first or cube root first. It's your choice, whichever works easiest. Now, over the years of teaching, I've definitely found that most people choose to do the root first because then that makes the number you're working with smaller, because taking a root of something makes it smaller, and then doing the power last because it's just easier to work with. But if the numbers you have, if it works better to do it one way or the other, go for it. So in the example, I'll actually work it both ways. I'll start with the one that I think most people would choose first. So my first example is going to be cube root, because it's got a 3 on the bottom, and then I'm going to square it second. So cube root of negative 125 squared. So this is one way that I can take the rational exponent and change it to radical form. So cube root of negative 125 is actually negative 5. And then if I do the squared last, negative 5 times negative 5, 25. Perfect. Okay, well, the other route is if, for whatever reason, if you find it easier to do the squared first and then the cube root second, you can do that. So I would write that as negative 125 squared cube root of that whole answer. But again, this is still considered radical form. These are two different ways of radical forms. Now, I won't lie, I had to look up what negative 125 squared was, which is kind of the downside to this method because larger numbers, not always something you could figure out in your head. So negative 125 squared is 15,625. And again, I kind of had to resort to the calculator for this next step. The cube root of 15,625 is 25. So you should get the same answer either way. I'm going to kind of go on the assumption that most of you would prefer to do this first. Okay, nice. Let me put up there's one for you to try on your own. So if you want to pause it here and try these, and again, if it can simplify, do it. If it doesn't simplify, just go as far as you can. Okay, here are the answers if you did those problems. So 64 to the 1/3 power could be written as cube root of 64. The 1 being on top would mean 64 to the first power, so I'm not going to actually do that step. But cube root of 64 is actually a perfect cube, which is why the answer was 4. 4 to the 5/2 power, I'm going to do the square root of 4. And as a reminder, when you do square root, you don't actually write the number on the radical symbol. So square root of 4 to the 5th power. Square root of 4 is 2 to the 5th power is 32. Okay, 625 to the 3/4. I'm going to do 4th root first to make the answer smaller. So 4th root of 625, whatever that answer is, cubed. And then the 4th root of 625 is actually 5. I know it seems kind of weird that that small of a number comes from all that, but it does. And take that cubed, which is 125. So nice job if you got all three. So that's kind of switching from rational and radical, and just working with them. Okay, so let's try another example here together. So write each example in rational exponents and simplify if possible. Okay, so I've got the 4th root of 7 cubed, and the number I'm working with is 7. And then my root and power, I'm going to write up top separately. So the 4th root is going to be a number on the bottom, cubed on top. Now, if I can work this and do this and simplify it, I should. So 4th root of 7 doesn't work out nicely, so I can't really do anything with that. If you wanted to, you could cube 7, I guess, and leave it to the 1/4 power. But to me, that's a terrible circle. But that answer to me wouldn't be any simpler, so I would just leave it like this. Second example, I've got 11 as kind of the main focus. And the two numbers I've got are cube root, 6th power. So cube root would go on the bottom, 6th power on top. And this is kind of the example I was talking about a couple slides earlier. These two numbers, even though they kind of are done separately, they do work together. So if I have 6 divided by 3, I'm going to simplify that, and I'm going to write 6 divided by 3 as 2. and then this becomes 11 squared. So that actually does simplify. And you could leave it as 11 squared if you don't know what that is, but otherwise it's 121. Okay, here's some for you to try. So change them to rational exponents, and then simplify them if you can. So pause the video here, take a moment to try it out. Okay, now that you have tried them, here's the answers on the bottom, and I kind of put a little bit of work with them if you needed it. But they're all somewhat the same. You'll notice on A and B, they're pretty much the exact same style question, just kind of written differently. Where on A, the root was written kind of first on the inside and then cubed on the outside. B and C had the power kind of on the inside, but it really doesn't matter. It doesn't change how it works. Okay, now there are some different properties that we have gone over in the past. You know, this is kind of just your refresher. So if you need to, you could pause it here and kind of look these over. But the product of powers property kind of states that if they're multiplied, you add their powers. Sorry, let me get this little cursor thing here. So you can add their powers together. If they are divided, then you would subtract their powers, top minus bottom. If you have a power to a power, then you actually multiply the two powers together. If you have a power on multiple things multiplied, that's terrible phrasing, but the key part here is that there cannot be any addition or subtraction inside. If this is all multiplication or division, number 4 and 5 kind of go together, the power can be applied to everything on the inside. So whether that's multiplication or division, the power can go to everything on the inside. There cannot be addition or subtraction separating terms. And I see an error that I wrote down here. Just because I was so used to writing M and N above, this should be an M on the bottom. Okay, now we're going to use some of these properties on the last final, examples here. Because I thought maybe you'd need that refresher. So I've got 25 to the 3/5 and 25 to the 2/5. If I would do them individually, well, neither one works out nicely. But kind of similar to, I think it was a problem we had in the last video, neither one worked out great, but what I can do is I can put them together first because they both have the same base. And so what I'm going to do is I'm going to put them together as a single 25 and add their powers together. Which would become 5/5. So we've got 3 of the 5ths plus 2 of the 5ths would be 5 of the 5ths. Now if I wanted to, I could do this as 5th root and 5th power, but again, these two numbers actually work together, and 5 divided by 5 is 1. So this is 25 to the first power, which is 25. Second example, I've got 8 to the 1/3 divided by 8 to the 2/3. This one actually can be done two ways, and the reason it could is because the cube root of 8, both of them are cube root, works out nicely and evenly. So if you wanted to do it that way, you could. So maybe I'll even write both ways. Honestly, if you have a problem that has multiple properties or steps, it's often kind of your choice how you want to do it. So the way I was intending to do this was that they both are a base 8, so you would subtract their powers. So I would do the top power minus the bottom power and turn that into 8 to the negative 1/3, which would become the negative puts it on the bottom of a fraction. The 3 becomes cube root, and that would become 1/2. Now, if I want to do it the other way, it still works. So if I wanted to do the top as cube root of 8 and the bottom as cube root of 8 squared, that would give me 2 on the top, and then 2 squared on the bottom, which is 4, and you'd get the same answer. So it's okay if you saw it a different way. The one below here written in white is kind of the way it was, supposed to work out because that's the properties, but it's up to you. Okay, well, I wanted to show you some examples of working that. So here's some if you want to try on your own. Okay, pause it here, try out the different properties, see if you can figure them out. And I've got the answers down here on the bottom. So the first one was intended that you would add the powers together and get 4/8, which reduces to 1/2. And then that would actually just lead you to doing square root only on 36, which is 6. Second one is actually almost exactly what happened on our last example. The negative means it moves to the bottom of the fraction. The cube root is the 3 on the bottom. So this means I'm going to do it on the bottom of a fraction. This means it's cube root. So bottom of a fraction, cube root of -8, which would give you 1 over -2. C, sorry, I scrolled a little too far. I think it's a 9/4. So we've got 5 to the 9/4 divided by 5 to the 1/4. So you're going to subtract the 2 powers and get 8/4. And 8/4 is the same as 2. So then that would be 5 squared, or 25. Okay, so this is a lot of different work with rationals and radicals. And, that's pretty much what there is. Honestly, it usually takes a decent amount of practice for you to get kind of fluent at it, or comfortable working with them. So don't worry if it feels kind of difficult at first. This last example I put up here, honestly, is just to see if you know how to type things in your calculator correctly. Because, well, at this point, all of the calculators are set up differently. And if you're dealing with rational powers, it'd be a good thing for you to know how to type in. So here's one that I would like you to pause the video, type it in whatever calculator you have, just to see if you can figure out the answer. Now that you're back, this is how you would type it in if you have a TI-83. So a TI-83 at this point is kind of one of the older graphing calculators that doesn't let you write things how they appear on screen. If you had a TI-84, I'm going to assume that you would just type it in exactly like this, where you would type in 64 parentheses 2, and then when you hit the power button, it's immediately going to put it up here, and then when you're in the power spot, you would go to the fraction button, and then that would allow you to type in the exact fraction, and it would come out exactly how it appears there, and so you know you're doing it correctly. But on different calculators, you don't always. So you'll notice down here, the 64 is kind of times everything, and so I put that first, and then I've got this parentheses that kind of encompasses everything inside the parentheses up top. And the 2 to the -3/12 power, the way I would type that in is 2. This is the power button. And the -3/12, the only way I would really know for sure that it's typed in correct is if I use a separate parentheses for that fraction. And so I would have to kind of type it in like this. I know from personal experience using a calculator like this, what I would frequently do is write it out by hand on paper first so that I wouldn't get really confused trying to type in parentheses like crazy on it, because on the calculator they can appear confusing. But either way, if you did it correct, the answer is approximately 53.82. So if you got that answer on whatever calculator you're using, nicely done. Okay, that's it for the whole section. Good job. That was a big section. We had 2 long videos. Okay, nicely done.